remember to hit record so I don't have to pull it down later. So I think the quality's not as good when you do that. Not like anybody wants to see me in high def anyway. So yeah, then we're gonna talk about anti-patterns, and then like the last 5 minutes of class, we'll talk about your homework because it's a little bit different than what I've had you all do before. So I want to make sure that everybody gets a feel for some of these patterns that are out there. So hopefully it shouldn't be too much of a stretch for you all. So yes, that's exactly what I just said. Look at that. We'll do some examples as well. We'll look at some of them. But just to review a few things, I've got a few slide-dos here that I'd like you all to kind of participate in. And I'm kind of glad that I am doing this on Slido today because I noticed that Discord is having some weird problems going on. It was down for me for a solid like 20 minutes and I can't authenticate anything to my Discord single sign-ons. So the ping bot for class, I don't know that is actually running. Yeah, no ping that class is in session. But first up, what is a singleton pattern? So if we remember from way back when, singleton has a few particulars here, right? So we have a private instance, we have a private constructor, and then a public call to get instance. So my question for all of you is, what is a singleton, and when would you use it? So this should be like just a little text entry field. So if you can, somebody can maybe put in an answer, or some of you can try to take a stab here and see if you remember. And I guess while you are all, yeah, I'll just wait to see if anybody has a guess here. I've got to double check that Slido's working. So it feels like half the time my technology stack is either slow or doesn't work. Come on, there we go. The other fun fact is I'm on babysitting duty today, so, well, not babysitting, they're my kids, that's not babysitting, that's watching your own children. But my wife had to run to the doctor, so I am, hey, what's up? Okay, I got another one here for you. Anytime. Have fun. Single instantiation of an object with a global point of access. Why would we use that? So that's a perfect answer. Restricts the class to one instance. I don't know when you'd use it. Well, that's why we're reviewing this, to make sure that we know why we use these things. So that's exactly right, both of those. We have a single instance. Now, why do we use that? We use that because it's possible that we need some common construct across our entire application, right? I've used multiple times that random number generator example so that everything pulls from the same data set. You could also think of like a global cache of information, where you only instantiate it once so that you only have one memory block of data, but every single other part of your application could pull information from that. In our in-class discussions, we also talked about instantiating like enemy sprites or tiles or things of that nature, where instead of having, 1,000 separate instances of some object, you only ever have one, and you just kind of repeat that over time. Can you use multiple design patterns within a single application? Absolutely. So that's one of the things that we're going to be talking about. We talked about a little bit last time, and I'll ask you, but with the model view controller design pattern, if we remember that one from last time, right, that's where we separate out the view, we separate out the database logic, we separate out the routing or the information, like kind of like the glue between database and front end, right? That's your controller. You could put an observer on there, right? If something in your database changes, notify all of your respective views that they have to update via the controller, obviously. So yeah, absolutely you can put multiple design patterns on top of each other. What we're going to talk about today, so why wouldn't you always use a singleton? That's a good question, and it's something that a lot of people don't do, but they should be doing. So there are pros and cons to applying design patterns. Singleton, in theory, you shouldn't modify it once it's instantiated. Again, we talked about it, I think, 2 classes ago. You can technically modify it as long as there's only ever one instance. So if you need like multiple copies, people should always be using. You should use a singleton where appropriate, maybe is a better answer to that. Right, let's go back to the game example where if you have multiple types of enemies, you don't necessarily want a singleton representing your enemy, because then you'd have cookie cutter, everybody's the same, they always have the same stats, they always have the same everything. But if you wanted to represent like the entire sprite sheet, right? So like if you've got a 2D game with a bunch of images and you only want to load that image one time, and then all of your separate classes pull from that, that would be a good target for a singleton. So the kind of the point is use these things where they're appropriate, right? Use a singleton if it's necessary to use a singleton. And if we look at the design pattern here, sorry, the class diagram here, it's super easy to instantiate, right? Super easy to create. It's just a class with a private constructor, and then a call to get instance. So it's not like it's too hard. But if you ever need multiple copies of an object, right, multiple, I guess I should really clarify here. You can have copies of an instance, but they're going to point to the same object. It's like copying by reference, right? You just point to the same memory location from multiple spots. So you change something in one, you change it for all of them. That's your shallow copy. There are good uses for a singleton, basically. So yeah, good answers there. So next up, facade. This was the second one we talked about. If we remember, it kind of looks something like this, right? We have a client, we have a facade, and then we have some classes behind the scenes, right? Client calls facade.operation. The facade class itself calls the other objects. So then another slide for you here. What is a facade? And why would you use it? When would you use it? So think of this like an ungraded pop quiz. I'm trying to think back to my undergrad years if I ever had any pop quizzes. I think by then we realized that pop quizzes were not always a good idea. And while you're doing that, I've got something to report here. We had an emergency over the weekend. My poor... Refocus, please. Have I been super fuzzy the whole time, or just now? There you go. My poor student watcher had a accident this weekend. One of my lovely children knocked him off his perch, and his foot broke off. So I can't have him glaring at students anymore. Although I kind of like doing this. This is nice. Nothing crazy glue won't fix. Interface for other interfaces in the subsystem. It's used when the user may not need access to all the system. Yep, good answer. Serve an interface, complicated code. Yeah, I would say those are definitely very good answers. So if you remember from, okay, so hide certain function calls. Advanced users, okay. Yeah, so that was the one thing about Facade. So that's definitely a good answer right there. Um, it gives you a nice common interface for the most common operations, but it doesn't hide things from advanced users. Right, so the example we talked about was that washing machine where you instantiate all the separate subsystems, wash, rinse, spin, everything that we do. And then the Facade calls those in the correct order. But there's nothing stopping you from calling them by yourself if you have API access or if you know exactly what needs to be done. I think we talked about extending it to be like a high efficiency washing machine or something like that. Yep, good answers there. Good, good, good. So we remember Facade, we remember Observer, or not Observer, Singleton. And I'm going to assume that you could take a class diagram like this and implement it in Java or whatever your programming language of choice is, right? I mean, it's pretty straightforward, I would think. Define a class, define classes, and then have them associate with each other, right? So in your client, you would have to extend Facade because you need to import it and call its operations, or at least create a local instance of the Facade object. And your programming language of choice may handle that differently. All right, so I don't think I have a slide for this one. Yeah. So observer, this one again was where we had the subject and we had a bunch of observers that could attach or detach themselves, right? Hey. Oh, thank you.
It's not
For the kids? Okay. You all get a bow tie. It's Play-Doh time. Thank you. Okay. Okay. It's like bring your kids to work day. So yeah, the subject basically we have a list of observers that are watching for state change, right? You are lucky because the afternoon class isn't going to get this. Um, but the observers will attach or they will be attached or detached when they need updates, right? So not every observer needs the information at all times. So for instance, if I have say this is my subject, it's my coffee mug, it is nearly out of coffee. Once the state is empty, my coffee machine could be notified to start brewing again. That's a great term project for next semester. Put a little like weight gauge on the bottom and maybe a little Bluetooth module or something lightweight, and just once it gets empty, ping an Arduino to kick off the coffee machine. Hey, perfect. There you go. That's not a term project, that's a senior project at that point. But we have subjects, we may have specific concrete subjects where we specialize them. Right? We don't just need one. And then we can have any number of observers which are specialized as well. The key is that they are getting notified by the subject that something has happened. And it's going to be particular to whatever observer you care about. Right, so if you look at this UML diagram, we can see it's getting more and more complicated as things get more complex. Right, so if we have to maintain a list of observers that we have to notify, then we have to have the correct associations, the correct privileges for notifying them, things of that nature. If coffee, empty, refill, else drink, pretty much. Yeah, so when would you use it? Can we use it with MVC? We already kind of talked about this, right? This is when you have a nice separation of responsibilities where you have a bunch of nicely singularly focused classes, right? Go back to the game example, we have a player, could be our subject. Anytime they perform an action, the rest of the game classes might get a notification that something has happened. Player moved, notify the world map that the player has changed locations. This might result in collision detection, logic being executed. Maybe the camera is moving based on the player. And there's a lot of examples you can take with this kind of a thing. Anytime anybody needs a notification. All right, visitor. This is where it starts getting more and more complicated, right? We see a very messy-ish class diagram here. Basically, we are composing in different types of behaviors at runtime. right? Depending on who needs to be brought in, we will call their related operations. So I actually have a slide for this one as well. But if we remember here, this looks a little bit different than the one I showed you last time, or 2 times ago now. It's the same diagram, it's just laid out a little bit differently. But we have our visitor high-level interface here. We have our specific concrete classes for your different visitor types. You have the elements or the visitables, based on which slide you're looking at or your notation that you want to use. We have an element who can accept a visitor, and we have concrete elements, which are specializations of that high-level element, right? So each concrete element can accept a different visitor if they want. Does it have to be this complicated? Not necessarily, but this gives you the flexibility to have different types and different algorithms. So, Slido, come back. Last Slido, I promise, and then we'll get into anti-patterns. So what's a visitor, and when would you use that? I guess maybe the better question is when would you use it, since I just said what it was. There are no emojis for coffee? Jeez. What kind of platform is this? Okay, it's not in my searchable list. Is it just cup? No? Mug? Weird. Okay. Sorry, it's not in Streamlabs, I guess. Visitor would be used when the class is fixed, cannot be changed or to separate. Yep, so absolutely. So the example that we talked about with visitor was that you have some kind of a packaged class that you cannot change, right? So it's fixed, which is a perfect answer here. So that would be one reason to use it, right? We might encapsulate it and then bring in functions to extend it effectively. Separate the algorithm from the object structure. Also a great answer there. We are allowing multiple algorithms to come in. Emoji for coffee. There you go. Yep. So lots of reasons to use visitor. It is tricky to implement, more or less. It relies on a lot of associations and inheritance. If I was mean, I would make you do the visitor pattern. But this semester, I'm thinking I don't want to be too mean with that. But definitely a good one. All right, so MVC and MVP. This is the one that we talked about last time, right? If you type cough. Franker face extension. Yeah, so in slobs, it's, I don't know that I can do that right in the text box, but that's outside of class. So MVC and MVP, this is what we talked about last time. These were two very similar patterns where we are separating out responsibilities from the back end to the routing to the front end, right? So your view is the front end, it's what the user sees, meaning that these patterns are quite good for like GUI applications or any kind of user-centric application. But we also talked about why would you go ahead and do these patterns, right? Regardless of MVC and MVP, right here where the view has a little bit more power, in MVP, the view is completely passive and simply presents information. Why would we use these over making a simple web page? Well, it goes back to maintenance, it goes back to usability, extensibility, reuse. Basically, if you have anything beyond a simple web application, implementing some of these patterns can save you time in the long run. I brought up the term technical debt a while back, and that's something that when we talk about anti-patterns here in a moment, you will hopefully see that the notion of the future work that you have to do to fix what past you has done There's going to be a trade-off in how much time do you want to spend. Do you want to spend a little bit more time up front implementing something like an MVC pattern or an MVP pattern? Or do you want to spend all this time fixing everything because you just hacked it together quickly? And now updating a view means that you also have to update everything at every other point of the application. It is literally a trade-off, an analysis of what your time will be spent as doing. But if you need a soundbite takeaway for the difference between the two, here the view has a little bit more responsibility in MVC. In MVP, the view strictly is separated out from all logic. It is literally only a pretty interface that doesn't do anything other than present data. The presenter is basically like a view and controller together in one. So you can kind of see here, the presenter and the model are very, very tightly coupled and woven together. They're still separate entities, but basically there's more back and forth there. The presenter or the view just shows what comes out of it. Why would you use MVC versus MVP? So that's a good question and something that we're going to talk about here in a second. So with MVP, it depends on your perspective as well here too, right? So both of them you could use for similar applications. MVC has a lot more entrenched usage, I would say. If you search for MVC and MVP, a lot more frameworks tend to use MVC. That's just my non-empirical look into things. But MVP actually gives you a much simpler user interface. So with the MVC framework, it can be a little bit more complicated because there can be logic in the view, right? So there can be additional responsibilities that the view performs. With MVP, all you are showing is information. You are making no decisions whatsoever. That makes it a simple user interface to code up. It means the testing will be a lot simpler. You can very easily swap views, and you have zero impact on the presenter. You have zero impact on the model. Whereas with MVC, if you start swapping views, there might be extra hooks in there that you have to try out. So in theory, testing MVP is easier. We haven't talked about testing too much yet, but if you're doing things like user interface testing, you're running a bunch of like maybe automated GUI clicking tests, or you're doing checks of values or things like that. Looking at the view becomes a lot simpler. The harder testing will be at the other layers. So it's kind of a, where do you want the effort to be, and do you want the view completely separated from your application or not? Would MVC be more interactive for the user? So that's actually a good point. So this is all programmer centric. The user is not going to care. The user is just going to see whatever is being presented, right? MVC is going to be for your project team, or MVP as well. So this is all stuff happening behind the scenes. So remember, the users are just the people interacting with the system and probably breaking them, because that's what users do. This is to make your life easier as a programmer or a software engineer, basically. Make sense, or is that still unclear? Okay, good. Good. Yeah, so you have to kind of, this is one of the hardest things for me to do as an engineer, is to separate the programmer personality from the project manager or the software engineer personality, where it's not just plopping down code and getting things working. It is analyzing how much time it will take to do things over the course of the whole project, right? You actually have to think ahead, which is tricky sometimes. If I am making a very complicated web application, all right, no, let me show you a quick off the cuff example here. So I'm starting to play around with some text generation to kind of hook into my little game. And it's nothing complicated yet. I've just got some code here, right? So this is my view. So I've got my little game map here. I've got some text. I've got a field. I can move east. I can move, should be south, not down. And if I go to the correct location, you win. So this is my view. I have done zero effort in terms of separating things out into responsible entities because this is just quick prototype, right? The goal is to hook all of this logic in with my other thing eventually. Clear. Python camera dev, right? So I want to take all of this text that I'm working on and throw it in here and say if I'm in this area and I click look around, I'm going to get this is a beautiful waving field of wheat or something like that. Now, if I want to actually take all of this effort that I did in here, I'm going to have to do a hell of a lot of refactoring to bring it in. And again, that's my own fault because I just am hacking this together for fun. But if I did this in a nice MVC format, my model would be all my data on the back end that I'm, generating all this text and all this fun stuff. The view, I could just swap between terminal, graphical, browser, all that kind of stuff. And I have very little effort to change. Whereas now it's going to probably take me a solid week of effort to move things around. Did I get something up and working really quickly? Yes, it's working okay, but it's not really deployable at this point. It's just, this is neat. It's not ready. So that's kind of why we do these things, these patterns, to basically make the development process easier. So we talked about MVC in terms of the web, and I showed you CodeIgniter, right? So that is one of the common PHP frameworks. I also mentioned Cake PHP is another one. If you want to go a different language, there's Django. I believe that's Python, if I recall correctly. Ruby on Rails, also an MVC framework. You do struts. ASP.NET has MVC capabilities, which should now be like C#.NET or the .NET web applications. Basically, you can implement this in any language, and it doesn't have to be on the web. It can be a console application. It can be a terminal application. It just depends on what you want to do. So if we kind of take the example of the website, just to review MVC a little bit more to make sure that it's clear, here's an MVC type of view with the browser and the server hooked together here. So the view in this case would be your web page, which HTML, JavaScript, cascading style sheets, whatever your front end is going to be. So this is your view. Your controller is going to be the thing that takes your user calls and translates it to what the model needs to see. So if I've got like a web form, you click submit, that might be a post call or a get call. That's an HTTP call, basically. I would translate that to my database. Or I might be clicking a button and I fire off a jQuery event, right? Still, I'm controlling what this logic is doing. And then I'm saying, get this information or do something to my view. So again, we are separating things out. And I realize here, controller and model look like they're kind of a little bit closer together. But this is just because they're in the same machine, right? These are still two separate entities. Arrows, not helpful. So again, same slide, same information here. The only difference is that, do we always need a controller? Might be a question that you have. Can the view talk directly to the model? It depends. If you have a simpler application, you can actually skip the controller as long as your view can talk to your model directly without having to do any kind of translation. So if you have a difference between what your view is doing and what your model has, right, again, translation, you will probably need a controller in there. Routing to different web pages, making different calls to the database. That's a great example for a controller. If my view is simply dumping something out from the database, possible you can skip the controller aspect. Not super extensible though if you skip it, right? Because at some point you're probably going to need that translation. And then here we have another view with adding in, sorry, another illustration where we show multiple views. So I could have different browser types. I could have a phone browser. I could have a Raspberry Pi browser. I could have a phone application rendering in HTML context. We're still going to get the same data, just formatted differently, right? So we're going to get different views. This is still MVC here, by the way. And there's a point here at the bottom, which if you look through the PDFs, you're going to see why not use MVP for the web. So this is the tricky part, because I would personally argue that you could use them both for the web and you could use them both for simple or complicated applications. So let me answer Abby's question first. I would say that you would use MVP when you want your view to be completely separated from everything else. So if you don't want your view to ever be able to talk to the model or really make any kind of decisions on its own, then use MVP. If you want your view to have a little bit more power, use MVC. And again, when I say a little bit more power, a little bit more interaction, I'm not talking about the user. I'm talking about your class diagram for MVC. So I don't actually have the class diagram here, right? And we showed the package diagram. Like if you want your view to talk directly to the model through like a function call, that would be a good use for MVC. MVP, this will never be allowed. So that's kind of the distinction there. And it depends, like if you're going to do testing in a specific way, use MVP or MVC, just depends on your perspective. Now, this also applies to different languages, dark theme, light theme, ECT, Ecto. Yeah, I could definitely see that. Here is your dark view, here is your light view, here is your pastel view. Here's rendering it in Cyrillic versus English versus, any different character set that's out there. Or language, yeah, absolutely. Yeah. Oh, awesome. Okay, I'm still in class, honey, okay? Yeah, I know, it broke. It's okay. Okay, so anti-patterns now. I've shown you a handful of normal design patterns. There are a ton out there. Remember, check the wiki link for basically the current list. Anti-patterns, there are a ton more. And this is a good thing to realize, basically, where you could be doing something wrong and not realize it. And this is known as an anti-pattern. And I've got the wiki page here pulled up because this is a really good resource where there are just a ton of these patterns out there that it has been found time and time again that this is not a good thing to do. I'm going to talk about a few of them here towards the end. But let's look at some of these really, really quickly here. So, magic push button, a form with no dynamic validation or input assistance such as dropdowns. So this is considered like a web anti-pattern where I have a web form and there's no validation being done, right? You don't help the user at all. You don't give them any autocomplete suggestions. So this is not really a great current example of a good web form. We can have poltergeists. So this is a fun one to talk about. So this would be an object-oriented anti-pattern. Let's say that you create an object and its only responsibility is to take information from here and move it over to here. Well, then why do I even have this object? It seems like an extra memory that's being taken up, right? If you're using it specifically to like separate out, different packages and maybe it's acting as a mediator, well, fine, but then it's going to have other responsibilities as well. Kind of some of these things are hopefully common sense or self-evident, but it's very easy for some of these to kind of creep in. And identifying anti-patterns is one of the things that you should be aware of when you're writing object-oriented code. All right, one other thing I wanted to talk about, which is really specific to you all in a way, is the project management anti-patterns. These are things where it's almost at a higher level than programming. This is a software engineering problem. So the Death March. This is a fun one. Think of any video game design company ever has probably gone through something like this. A project whose staff, while expecting it to fail, are compelled to continue, often with much overwork by management that is in denial. How many projects have you heard of in the industry where everybody knew it was going to be bad, yet they still put it out? Like, why would you do that? Every Sonic game ever, yep. Pretty much. So you can kind of look at these and say, hey, I kind of understand how this could happen, and these are the things to avoid. Follow, yeah, there you go, 76. Gold plating. This is a fun one. Continuing to work on a task or project well past the point where extra effort is not adding value. So I'm just adding on extra features for the purpose of adding on extra features. Why are we doing this? There's no value to us as a business, as an engineer, no purpose, right? So let's talk about a few of them. And honestly, I would recommend reading through this because it's a great wiki page on all this stuff. Yes. So this is one of the most common ones that are out there, especially if you're just getting started with programming, the God object or the God class. Remember last time we talked about cohesion, where classes should be very singularly focused? A God object does way, way, way too much, or it knows too much. If you see a class where you start seeing multiple responsibilities, right? Like it's not just doing one thing well, it's doing a bunch of things, not that great in a way. So break it apart. So here we have a Java class for an employee manager. So we have a bunch of employee specific functions. We have vacation time, we have addresses, bonuses, equipment, raises, scheduling, phone numbers. Logically, you could look at this, and this is snipped, by the way. There's a bunch more functions in here. You look at something like this and say, yeah, that could be tied to the manager, but there's way too much going on here. This needs to be broken apart into subclasses or other separate classes, right? A class needs to have a single focused purpose. So break this apart into the responsible parties and then associate them with each other. If any of you have done like database classes yet, the idea of normalization basically applies to something like this. Have your classes focused on one job, just like you have your database tables focused on one job. You know, don't have a lot of overlap or duplicates or things of that nature. It can lead to very bad things like duplicate memory or things of that nature. Okay, so God object. I mentioned it before. This is what it actually looks like. I just picked a couple random anti-patterns to worry about because they're kind of fun to talk about, but all of these are fun to talk about. So there's the big ball of mud. This is a fun design pattern where you basically end up with spaghetti code. So how do you end up with a big ball of mud? Basically, you didn't plan your project out that great. Something that I'm seeing with my projects because I just am jumping from shiny object to shiny object with my my little game here. So very haphazardly designed. We have a bunch of random weird associations that don't make sense. We might have a lot of duplicate objects, duplicate attributes, duplicate methods, meaning that classes were designed not intelligently to have a single cohesive purpose. You know, the employee class here and the manager here and the HR person over here might all have the same add vacation time functions when only one should have that. You also have bad data hiding principles here. Some things need to be public, some need to be private, some need to be protected, and here we are just lazy and make everything public. Easy to program, but very bad from a design perspective, right? So everybody gets access to everything. Great way to make your system hackable, by the way. All right, I've got a couple more here, 3 more here. So there's the law of the instrument. This is a fun one, and this is a trap that a lot of people fall into. Basically, you have a silver bullet that will solve every single problem ever. So silver bullet, golden hammer, the thing that always works for you. Basically, you get comfortable with an algorithm or a design pattern or a particular class setup, and you just use that everywhere, right? Because you know that it works. This is the computer science professor saying if you have a hammer, use it for screws, for nails, for tacks, for staples. Just gonna use that hammer for everything, right? Actually, so that's a bastardization of this quote here, I'm realizing now. But basically use the same thing over and over again, even when it doesn't make sense. So you get stuck in a comfort zone. Everybody does that, right? We figure out how to program something. We're very pleased with ourselves for learning how to program that. It's cut off to the right. Oh, you know what? That's just my head. Oh, no, it's not. What's going on? Oh, I'm sorry. You know what? Let's do this. Thank you so much. There we go. Better? We finally fixed our office setup here, so I'm back and my monitor that I've got here is way bigger. So thank you for that. Um, so I am more than happy to point the finger at myself for this one. I love genetic algorithms. I think they're fun to write. I think they're super nifty in what they do. If you don't know what they are exploratory algorithms that solve themselves, basically. But I apply them anytime I have a search that needs to be performed, even when it doesn't make sense, because I think they're cool and I know how to write them. And I can write them with my eyes closed more often than not. But if you have like a numerical optimization problem where you need to find an answer very quickly and there's only ever one answer, there's a good chance I still use a genetic algorithm, even though something more better suited for that problem could be used, like a gradient descent or a Bayesian optimization or something like that, to go use big terms that um, are out there, but not specific here. Basically, I like them. I use them everywhere, but it doesn't make sense all the time. That's this golden hammer, silver bullet idea. All right, cargo cult programming. This is a fun one. So cargo cult is a reference to World War II, where natives would build runways or mock-ups of runways, mock-ups of military like tanks and stuff to summon the gods to come land and bring them supplies. So this is a real thing that happened where, hey, if we mock this up, you will come here and bring your people and your supplies and help us. What this means for programming, this is actually a term that's out there, is that you as programmers don't understand what's happening, and you're just going to apply some pattern or some practice and hope that it works. So think of it like you slap on a design pattern, some of the things we talked about to one of your problems, and hopefully it's going to fix things. Or you switch over to Agile from Waterfall, or you use Spiral or extreme programming because it sounds cool, but you don't know what it's doing and you don't know how to implement it. This is kind of that notion where somebody else is going to solve your problem magically, basically. Hopefully I don't have to explain to you all the danger in just randomly applying algorithms or patterns or processes or something like that. If you don't know what it's doing, then how can you be sure that it's going to work and not introduce more problems, basically? All right, last one, dependency hell. I like this one. Let me move my head out of the way here. Because you can see these as class diagrams in a project, or dependencies to external libraries or modules. Very, very quickly, your projects can balloon in craziness. Okay, so if these are all modules, makes sense, right? Maybe you need them all. I mean, the one on the right here looks like a normal Node.js application at this point. But think of all the versions that go with these. How do you know that you have the exact correct version of this one package right here is when you developed it initially? Plus, think of how much memory bringing these things in is taking up, or how easy it is to accidentally have a bad association. Basically, have dependencies, but make sure that you're not going way overboard with them. All right, so anti-patterns and design patterns done. Hopefully everything makes sense. Now I wanted to talk about the homework really quickly because You've got 2 weeks to do it. It's not specifically related to your term project, but I want you all to be able to do something technical in the class related to design patterns. So what we've got here is I want you to implement a model view controller pattern. So I've got some information here. Read through the PDF or the document and let me know if you have any questions or you need clarification. Basically, consider it this way. I have a problem where I need a storefront developed. So I want you to create a simple application where you show a listing of products, and then when you select a product, you show that product's information. I don't care what language you write this in. I don't care if it's a web-based, a GUI-based, a terminal-based, doesn't matter. If you're doing a terminal, item 1, item 2, item 3, I type in 2, I get item 2's information. Can be as simple as you want. Don't spend a lot of time making this super pretty for me. I suppose you can if you want, but you don't have to. But basically, I've got some details here. So I need at least 2 views. So a product listing view, a detailed view. You should add 3 products with some basic information. So just think of like adding a instance of a class, right? Instantiate product A, instantiate product, A, description, title, price, product B, description, title, price. So like don't go crazy and add a database and all kinds of off-the-wall things if you don't want to. The thing that I care about is that you're writing an application where the responsibilities are clearly separated. And I've got some etc. things here. It doesn't have to be a real store. I'm just looking for a prototype, like a little mock-up type of thing here. But what I am looking for deliverables, I want to see a class diagram. I want to see well-commented code that's runnable. I want instructions for how to run it, and then screenshots of it working for you so that I can replicate what you did. So I don't want you to think that this is going to be something that's just going to totally kill the time you're spending on your term projects. But I want you all to have practice with MVC, basically. Like I said, if I was mean, I would have given you Visitor, but I figured MVC would be a little bit more achievable in the semester. So read through this, let me know if you have any questions. But does this make sense more or less? So what I'll be looking for is this report filled out, your code, and your screenshots. So if we are all good, that's actually the end of class. So it's a good idea to make the MVC diagram before you start programming. I would. So what is your model? What are the attributes? What are the functions? What are your views, right? Because you're going to have 2 views at least. What is your controller? How is it routing from model to view? Again, it doesn't have to be super complicated, but it should demonstrate separation of responsibilities, which is what we're going for here. Alrighty. If we are all good with this, I will see you all on Wednesday. And again, if you're looking at this and crapping your pants because I'm making you actually program, keep in mind I don't care what the language is. Use whatever you are most comfortable with. If you are using something different, you need to tell me what I need to install though. Pretend like I don't have anything that you do on your computer. If you're doing Lua, tell me you're using Lua. If you're using HTML and JavaScript, tell me that. If you're using Python with all of these modules, tell me Python, the version, the modules, etc., etc. But have fun with it. It's kind of a nifty little project, I think. So good luck. I will see you all on Wednesday. Corey's got a question. C. You can do it in C? Absolutely. Do it in assembly and I'll give you, I'll send you props. How's that? Do it in machine language and I'll maybe nod my head slightly in your direction. Alrighty, see you all Wednesday. Bye. Bye, everybody.